And welcome back to the session on day 2 of Power Climate. I'm going to run this quick this time. So we are going to be talking about using AI for a more sustainable food system. And the talk is being given by Lara Martini. She's a senior advisor at TheoryMesh, and she's an active community member. She's currently acting as an advisor and mentor in the green tech sector, supporting startups in their growth journey. She's a strong advocate for the positive role that businesses can play in addressing society's challenges through innovation. She comes with a varied background in roles spanning global marketing, strategy, business development, and a lot more. She holds an MBA from UNC. She has certifications in international relations and ESG investing. With that, I think we're ready to hand it over to Lara, but just a few housekeeping things. I would highly encourage you all to share your thoughts and, in the chat section, be as engaging as you would like to be. You are also welcome to share your LinkedIn or any other socials so others can connect with you. And specifically, if any questions you have for the speaker, please put them in Q&A section, and Laura will be able to take them on towards the end of the discussion. And with that, thank you so much again, everyone. And thank you, Lara. Over to you and take the stage. Thank you.
Thank you, Priyanka, for that introduction. Let me share my screen as well. And thank you, everybody, for joining us today. So today I want to talk about a few things. Oh, sorry. I want to share this one, and then I want to go back here. So today I want to talk about a few things about how we can apply AI to create a more sustainable food system. I'll start with a bit of a business overview of why this is important and why it's meaningful. And then I'll move us into a few cases, starting with TheoryMesh, which is the one I know best, but also a few other companies that have collaborated in different ways. And hopefully that will be a very concrete way to illustrate some of the challenges as well as the opportunities and the outcomes that we have with this. So let me move through this. Couple of things about me. Actually, I'd rather not take too much time since we're starting a couple of minutes late. But what's important to me is really bringing together something that is deeply personal in what we do with using technology and with serving others and serving society. I'll share my LinkedIn at the end. We're not too many, so if you have any questions, feel free to pop them in, and I'll try and keep an eye on the chat. I might miss it, but I'll do my best to keep an eye. So first of all, why are we talking about AI applied to food chain? The supply is changing, and the reality of the way we create food and we distribute and we share food and consume food is changing. We all know that food production is a significant contributor to greenhouse gas emission. And out of those, about 1/3 are really created through fertilizers, 1/3 are created by shipping, refrigeration, packaging, etc. And a significant portion is also generated simply by waste. Those are things that we have the technical means to solve. It's not easy, it requires collaboration, but we can do it. The other thing is food insecurity is on the rise. Food affordability has fallen, according to The Economist, by 4% recently. And we have seen more insecurity across more countries. We've also have seen an increase in food recalls and an increase in the cost of recalls. And part of that is because through food processing, what you do is you really mix and match products very much. So it's very hard to say, well, I have this batch that has been tainted, and to trace it directly. So recalls are much bigger than they should be, contributing to the problems. On the other side, we see consumers being willing to pay a premium for quality food, but unwilling to do that when they can't trust the brand or when they can't trust the label. And we see increasing confusion around labels. So organic, for example, has a fairly clear definition, but things like regenerative agriculture or green don't have clear definition, which confuses consumers and doesn't generate trust. In this context, the vision would be, what if we could recreate that trust? What if we could apply regulatory changes directly to the supply chain, especially when there is a divergence, such as what we have seen between the UK after Brexit, the EU, and North America? What if we could simplify recalls, have better collaboration, but also accelerate innovation? test safely more easily. And again, these are things we have the ability to do. If you think of digital twins and the way they've been applied to manufacturing, there's not a lot stopping us from applying them to food chains and applying them to different industries. And it's not only about security, because they've been also used, for example, in healthcare. What if we could reduce waste? What if we could measure and communicate impact better? A lot of companies today are struggling with scope 3 calculation, but their scope 3 is really somebody else's scope 1 and 2. So if we combine that well, we should have better quality of access to data. And finally, people really want to spend more on experiences and on things. What if we could connect our food to experiences? What if that story of the grower, that story of the producer that's putting their family expertise, their passion for food could be communicated better to consumers? We think that these things are possible. And we think that by using AI, there is a real opportunity. In fact, according to McKinsey, and this was from a couple of years ago, and it's only increased with COVID and with the war in Ukraine, they see an opportunity for 127 billion a year in value creation, just by reducing food waste, applying better traceability, applying better techniques, which are possible through technology. The outcome of that is investments in agri-food, and we see this happening across the board. So again, this is an opportunity that we're not seeing further away in the future. This is something that's happening now. There are investments, there are VCs willing to invest on this, there are customers willing to adopt. The landscape is still very fragmented. I see too many startup companies trying to do things end-to-end where they could possibly partner. We see a lot of clients building their own systems end-to-end where they could probably go for SaaS and for something mainstream. But we also see that in a market that's been very tense in the last couple of years, farm software and Internet of Things, so intelligent sensing, has grown nearly 10% year over year in terms of investment. And we see also pretty good global markets. So the UK, US, and India are some of the largest global markets. Again, cost, complexity of setup, fragmented market are seen as barrier, but that market is moving and the opportunity is now, and people bringing good skills like the people in this team are in the right place to do that. We also see consumers adopting, so large companies investing directly and investing in a very consumer-friendly way. So this is also something that I've seen. I used to work at Microsoft. I used to be in ERP, CRM, and this was considered something for large companies and considered backstage. Now it's coming to front end. How can we innovate more? How can we engage end users in co-creation around products? How can we use, for example, we'll see it with TheoryMesh barcode systems to communicate directly to consumers. And this is some of the landscapes and how this is turning into opportunities that are real today. It's just a sample of companies that I know or I've run across in different ecosystems, from the Netherlands to the UK to others. As you can see, quite a bit going on producer side and on more sustainable agriculture, resource optimization, probably a little bit less on forestry just because it's harder to funnel investments, a little bit on the consumer side. That traceability element, I'm willing to pay a premium, but I want to make sure I'm paying it for the right thing. And of course, because of the cost of food, we've also seen food smuggling increase. So that traceability becomes very important. And then other things that are happening at distribution and retail around calculating impact, around traceability, around certification, and at food manufacturing level. With that, I'll stop for a second just to check the chat, and then I'll move forward. No, I don't see any questions in the chat, so I'll take it as an invitation to move. So let me jump a little bit now into examples. And roughly you'll see that from a theoretical perspective, there's almost two scenarios in which things are used, which then translate into different applications. One is a very linear scenario where you're able to work in a controlled environment, such as manufacturing. There's an element of sample gathering. Some will be set aside for testing and some will and for validating results. Then you have an array of sensors, more or less intelligence, could be an e-nose system, e-tongs, computer-based vision, could also be simply gathering data from intelligent equipment. So for example, with TheoryMesh, we're going to see a John Deere integration happening at tractor level. Application of intelligent algorithms, and then results. And the results are often variations or optimization on things. So calculating things like the acidity or the sweetness of coffee, calculating, for example, the fermentation time and the optimal fermentation for cocoa beans, level of acidity, and so on, detecting antioxidants in honey, in glucose, in sugarcane. So there's basically a variation on, I select a variant and then I want to work on optimization. And that's why it's easier to control. And then you have broader scenarios where we're working on a broader array of data. And examples are carbon capture assessment, whether it's carbon capture in the soil, in peatland, whether it's crop optimization, and so on, where essentially we're looking at samples coming from public data, LIDAR, weather patterns, and so on. Direct capture, which would be done through manned or unmanned vehicles, could be done by satellite. So I purchase data related to my environment, and then data that are captured probably directly on the field at farm level or by observation. These get processed, and then the forecasts need to go through a validation effect, and there is an evolution of the model. And these are very much open models like we'll see with Forestry Commission in the UK. So one is a controlled environment application, which is a lot more linear. The other will be done on constantly refining the set and much larger data sets. The challenge that we see is often a misalignment in the time series. So typically when it comes to forestry, for example, long-term growth crops such as lovely olive groves and viniculture and so on, what you're doing is you're using a data set which is by nature relatively limited to calculate long-term performance. So the life of a tree in forestry commercially is about 80 years, which is what Forestry Commission will look at. But really what we're looking at is ideally the lifespan of a tree is 200-300 years. And so if we wanted to do things right, we'd be extrapolating over those 300 years, which is really at this point not realistic, way too hard. The other thing is you're using long-term series, such as weather patterns and expectation for climate change, into short-term decision. What should I plant? How much fertilizer should I use or not use? How much water should I use? And so that discrepancy in the time series is usually at the origin of some of the challenges. And again, I'll stop for a second, check if there's any questions in the chat windows. If you have any questions, please do send them. And if not, I'll be moving ahead. So let's look a little bit now at the case of TheoryMesh. So TheoryMesh, they're a Canadian startup. They started with the grain market and all different sort of grain from wheat, barley, and so on. And now they're expanding into other type of grains, including cocoa beans and chocolate and so on. And then we're looking at applications for dairy and other industry. And here what we're looking at is looking at how collaboration can empower the whole supply chain. So what does it mean for producers in terms of having verifiable data for shipping, certifications, and so on, contract compliance? And this is very important if you look at also leveling the playing field, because a lot of the large retailers have reporting requirements that are difficult to assuage for small producers. And so we're working, for example, with African communities on how can we help you with contract compliance. It can help food manufacturing in terms of, again, verifiable data labeling. And the challenge in industries like grain is often manufacturers are aggregators. And so recalls become complex because they will tend to mix different grains from different batches. But if we keep that traceability, we'll limit the impact in case of issues. We can also anticipate better customer wants and needs for innovation. Then we have the level of distribution in retail, and then we have the level of consumers. And again, the sense for consumers is also really connecting a food to an experience. I can drink my coffee and I can use a barcode to see where my coffee was from, where my product was from, where my apricots and my dairy and my yogurt were from. I see we have a question, so I'll see if I can take it. How do you create trusted data for consumer certificate? Does government need to be involved? So government is at validation level. You can't be the creator and the judge, but what we can do is we can digitize the information from farm level which often is still on paper, make sure that you have real-time access, because one of the challenges with production and agriculture and living system is that the data changes. So for example, if you have a requirement to communicate on greenhouse gas emission, 1 ton of grain can have between 1 and 3 tons, say, of embedded carbon, depending on the year, the time of year, the provenance, the soil, whatnot. So that variability needs to be reflected in real-time data. So what you do is you capture the data, you know what the requirements are in terms of, say, having a digital grain certificate in the UK or deforestation-free supply chain in the EU, etc. And you look for that data, you update it in real time. And ideally, and where possible, you make it available in real time. A lot of the audit processes today, even in the UK, are still analog in a digital world. People physically go to see, and then they see it, and then you're good for 2 years. And that, of course, is not the reality of how things work. So if you're able to communicate directly with your buyer, with your manufacturer, and with your government on data, that adds a lot of value. Are there gaps in data, especially for long-term phenomena? Absolutely. Well, first thing is you work and you optimize with what you have. So we try to combine different sources and extrapolate, but the interest of using AI is quite like in the medical field, you don't have to extrapolate on standards. So again, today, a lot of green gas emission calculations are calculated based on one sample. There's one data that says a 1 ton of barley is equivalent to X water, X carbon, X fertilizer. We can change that. So we can say, well, in this case, fertilizer was not used because we're doing agroforestry, or, you know, this crop was raised in the winter, in the summer, was raised in southern France or in Eastern Europe or in Manitoba province, and that will change the data. So you can play with that variability, and that gives a lot of insights. And again, when you're looking at manufacturing, then you're looking at linear series, and then your data is much more complete for the first scenario that I discussed earlier. So it's not always straightforward, but it is absolutely doable. And if I can move my slide forward, let's look into it. So let's look at the example of grain milling and the work that TheoryMesh has done. We're looking forward to sharing a customer name today. We're not quite able to do that. It's going to come in a couple of weeks. But this is a real case that has gone live. So essentially, what we've been able to do is gather farm data, not just manually, but again, through tractor and the IoT integration, and use it to reduce inputs. So seeing where we could reduce fertilizer user. And again, nitrogen is probably responsible for 10% of global emission if we extrapolate about 1/3 is agriculture, etc., and increase soil health. Then at processor level, we're trying to reduce waste. And that's very important. You can also predict more your byproducts. So there is all of an industry that's been growing for maybe the last 15 years around circular economy. So we're using byproduct from different processing for, say, from milling and malting to create flour, from waste to create chicken feed, and so on. And so the more transparency you can have, the better you can do that, and the more you can reduce waste. Then package good. And that's where you get into government certification and the ability to say, yeah, we know that the provenance is from land that has been used as agricultural land since whenever it was, since the 80s, let's make it up. So no recent deforestation per the EU law. And then consumers, again, with the opportunity to have a little barcode where you can say, yeah, I'm eating this cookie and I know where this came from. Let me check again for questions. No, questions are the same as before. So let me then move forward and show you what this actually looks like. So sourcing grain from farms, essentially what they have done is apply machine learning and AI to using multi-source data from the farm. So we've been looking at elevation, we've been looking at moisture, and well, elevation doesn't change in time, moisture does, as we know very well from Italy and the UK this year, for those who are in Europe. We've been looking at LIDAR data. We've been looking at precipitation And then we've been looking at what actually happened at the farm. So we've been looking at the application of fertilizer, we've been looking at seeding, we've been looking at what has been done, and then we've used it to predict yields based on the weather. And so if we know, for example, that it's more rainy, save on water, don't apply water, and so on. This is very important once you start changing and looking, for example, at no-tilling or agroforestry has been a big topic recently in Europe and so on. And then you can say, yeah, because I've increased the tree cover, I have increased the humidity and the moisture in the ground, and I have the ability to do less, as well as predicting greenhouse gas emissions. Now, looking at processing, what we've done is predictive models to minimize recall. Again, the example that I mentioned earlier about optimizing things like fermentation time and so on, tracking allergens and contamination, tracking higher risk supplies. Not everything has the same level of risk if you think of the cold chain and so on. So that's very important as well. And then we've been looking at related trends. So again, connecting those weather patterns to the risk of mold, connecting what's been happening at the level of shipping and, you know, the issues we've seen in Panama Canal with the drought this summer, with increased risk or longer supply chains. And interesting, that translates immediately. I was today at an event for food manufacturers, and they were discussing how they've been looking at diversifying sources, for example, here in the UK into Wales, because the longer shipping lines have more risk. So that allows you to do that sort of decision. And again, accurately predict food waste if there is. And also understanding if there is any wastage because of things going bad. So that all is very important for procurement, and that directly translates into cost savings, which then can either go to the consumer or can go to the producer, because if there's less waste, they get more benefit is given from their produce, and they can reap more benefit as well, because nobody has an interest in wasting produce along the chain. And then let's look at creating better products with AI. So we've used AI to recommend product processing implementation, for example, low carbon oat flour, low water usage at the plant for creating protein. And we all know, you know, water and sugar, etc., all go directly into the fermentation. And we've used AI back to that closed loop idea to improve the finished product and to drive requirements. We can also anticipate consumer tastes. So if we know that at consumer level, there is an interest for more crafty product, for sweeter products, for more savory product, for more umami, we can anticipate that through digital twins, and then we can implement and accelerate the loop of innovation. And moving forward, we can, of course, support sustainability as well. So reducing scope 3 emissions, why? Through procurement, because at the end, again, what scope 1 for the farm or for the transportation ends up being scope 3 at distribution level. Optimize the processing, reducing the waste, and creating better product. And again, we're not talking small quantities, we're talking big quantities. So, for example, there are concepts that are, if they're not clearly defined, there will be a cost. Let's say a loaf of bread. If I'm not sure about the fermentation and I think my loaf of bread is going to become a little bit smaller than what it should be, I will tend at factory level or at mill level to use a bit more product, because I want to make sure I give the consumer what they paid for. But if that translates into giving them 10% more, it's not just the cost of the product, it's also consumer has a product that has 10 or 15% more calories than what they expect. It's also transportation all of a sudden has 10% more way to transport. So the more exactly we can forecast, the better we will be in terms of savings and in terms of impact. And with that, I'll stop again for a second, because I think there's another question. What do we think are the most impactful application? If we can only implement one, you know, I think that really depends on the industry. So yeah, it is a good question, but I think in the end, this is demand and customer led. So in some market, for example, in the EU today, I would say making sure that things are deforestation free and that we can trace accurately and that we can spot and apply intelligence to spotting fraud and food contrafaction, super important. In other contexts, it might be, again, that product innovation. I would say for me, personally, something that I really like is that ability to level a little bit more the playing field and so to equip smaller companies, whether it's producers and food manufacturers or farmers, to be able to have the same level of documentation as bigger player. Yes, Priyanka, something I see that you popped in. Anything to say? I've taken questions as we go, so I don't feel too bad that we're still in the presentation. I have a few more. Sorry, go ahead.
No, I was just saying carry on. We just have a couple more minutes left, but please go on.
Okay, so I'll probably invite you to explore the other examples. The Planet has been applying AI specifically for growers and viticulturists in optimizing yields. These are all very good examples. Forest Research UK today is giving indications to small woodland owners. I happen to be one in terms of what we plant today. And again, somebody had asked about incomplete data sets. What we do is we apply intelligence by comparison. So for example, I'm able to drill on the map of the UK, select my piece of land, my 9 acres, and run a simulation whereby indications for weather patterns today, for all we know, tell me that my land will be comparable to a part of land in northern Spain and to some areas in central southern France. And so if I'm going to procure trees or crops, which is not my case today, or plant trees, that creates a reference. So rather than simulate a whole ecosystem, which is incredibly complex, they'll just say, in terms of trends, in 50 years, your land will look more like this. And we believe in 80 years, your land will look more like this. So the plants that are thriving there today are likely to thrive in the land that we have today. And that comparison and that analogy is also a very good model to try and support with data, complex ecosystems or incomplete data. Another good example is Edible. They're calculating emissions in hospitality, and what they're doing is they're using procurement. So there's a realization in this case that you can't do it at plate level just because that 10%, 20% variability in ingredients, I use basil from one area rather than another, I use basil or thyme, will change. But by looking at procurement, you can apply intelligence in a way that will be meaningful and will be material. So that's another way to palliate for incomplete or inaccurate data by just going one level higher. And then, I won't talk too much about circular economy. Don't hesitate to connect with me on LinkedIn. I'm very passionate about this subject, so I'm happy to discuss more. Just a couple of things. We've been talking quite a bit about numbers, but it's not only a number game. I hate when I see things like headlines like this. For example, trees planted by the number. We plant 1 tree for every 2 chicken or for every bag of cookies. Unfortunately, not all trees are the same. We have to take system thinking. We have to take biodiversity into account, as in the example I made with Forestry Commission. But data can be a game changer. It can give some comfort to your board that whatever you're announcing, you're not greenwashing because it's supported by data. It can simplify certification. Very important, particularly for smaller players, because they don't have as many resources as the big one, and they may fall behind in competitiveness and leveling the playing field. And with that, I hope this is of use. Please don't hesitate to connect. And I hope that, I hope to stay in touch.
Thank you so much, Lara. I think this was a great discussion, and it's amazing how data collection, is happening in this space, and how we can then, actually use it for using AI and for developing all those fancy machine learning algorithms. And I'm glad you've already taken up the questions, so we are on time for our next discussion. So again, thank you everybody for joining in. Thank you, Lara, for your time, for sharing your insights here.